Alright, for this last example, we're going to use the linear factorization theorem. The linear factorization theorem says I can use my zeros to write the equation of my polynomial. So let's start with this one. Write a polynomial function of least degree with real coefficients in standard form that has -2, 4, and 3i as zeros. So the first step you do is you list these. This is my C1 is -2. My C2, my second zero, is 4. My C3, my third zero, is 3 minus I. Now, I have a fourth zero that's kind of hidden here. They don't tell us what it is directly, but because this is 3 minus I can also assume that 3 plus I is a zero. This is because I is a square root, and every time we have a square root in a polynomial, it's going to be plus and minus. So 3 minus I is the minus version, and 3 plus I would be the positive version. The next thing I do is I write my polynomial f of x equals x minus c1 times x minus c2 times x minus, and then we have 3 minus I is our c3, and x minus 3 plus I. I'm going to clean this up a little, so that's x plus 2, x minus 4. That gives me x minus 3 plus I. And this next one gives me x minus 3 minus I. The last step we would do is just to FOIL this out. X times x gives me x squared. X times -4 is -4x. 2 times x is positive 2x. And 2 times -4 is -8. Then we multiply the second set. X times x is x squared. X times -3 is -3x. X times -I is -xi. Move on to the -3. -3 times x is -3x. -3 times -3 is positive 9. -3 times -I is positive 3i. Then I do the last one, which is I. I times x is xi. I times -3 is -3i. And I times -I is -I squared. We're going to clean it up for our final step. X squared, -4x and 2x gives me -2x and a -8. And then I'm going to look at this one here. I have a -3x, another -3x. So I have x squared and a -6x. I have -xi, positive xi. Those cancel each other. And I have a positive 3i and a -3i. Those cancel each other. Bring down my plus 9 minus, and I squared is -1. So my final answer is x squared minus 2x minus 8, x squared minus 6x, and 9 plus 1 will give me 10. There's a polynomial with those as zeros.